Welcome to Cloud Native Live, where we will dive into the code behind Cloud Native. I am Saloni Narang. I am a CNCF ambassador and also a co-founder at Cube Simplify. I will be your host today. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they break things, and they will answer your questions. In today's session, I'm excited to introduce Josh, who's a developer advocate at Alternity, where he applies his observability and engineering background to ClickHouse use cases. He has over 10 years of experience in developing and leading software projects for various clients and industries. Josh is also a speaker, a contributor to Open Telemetry and CNCF communities, sharing his insights and best practices on topics such as distributed tracing. And today he will be presenting on building a ClickHouse cluster on Raspberry Pis. So I would like to mention this before we'll start the stream. This is an official live stream of CNCF, and as such, it is subject to CNCF Code of Conduct. Please do not add anything to the chat or questions that would violate the Code of Conduct. Basically, please be respectful to all of your fellow participants and presenters. With that, I'll hand over to Josh to kick off today's presentation.
Thanks so much, Saloni. It's so good to be here. So today we're going to put together a little bit of a demo or a dev cluster. This type of project I think is really great for someone like me who comes from more of an app dev background to learn kind of what it's like to run things on bare metal. Maybe most of the time we're running things on the cloud providers. And this just forces you to deal with all of the networking and other things that maybe are usually just taken care of for you. So before I share my screen, I'll just go over the hardware that I have here a little bit. I have 3 Raspberry Pi 5s. The Pi 5 is important for this project because I wanted PCI Express for the NVMe hats. So each one of these has a 1 terabyte NVMe. They're 8 gigabytes and 8 cores each. And then I just have a little cheap switch that they're all hooked up to and a router to connect them to my Wi-Fi because dealing with the Wi-Fi on the Raspberry Pis while it would work, it's kind of a pain. Then I just have an HDMI capture card. We probably won't need this because, as I'll show, we're going to be able to boot the Pis straight up with SSH available and SSH in and do everything that we need from there. So hopefully we won't need this HDMI capture, but I have it just in case we do. And I got a USB keyboard just in case we need that. So let me go ahead and share my screen and dive into how we're going to set all of this up.
Yeah, so I hope you can see the screen now.
Yeah, looks good. Thank you. Okay, so the first step is to get an operating system onto the Pis. I think they come with an SD card sometimes that might have like Raspbian Lite or Raspbian already preloaded onto it. But even if that's the case, I would recommend just flashing a fresh SD card or the SD card that came with it using this tool. So this is the Raspberry Pi iOS imager. Raspberry Pi OS imager. And it's available for Linux, Windows, and Mac. And what it's going to let us do is we can choose, which device we're using. So I'm using a Raspberry Pi 5. A lot of these instructions that I'm going through today are going to be really specific to the Raspberry Pi 5s. If you're using a 4, you're going to have to look up different instructions because things like the NVMe, it's going to be a little bit different. Then we can choose which OS we want to use. So I went into Other so that I could choose Raspberry Pi OS Lite. This is just a fork of Debian that has some nice utility functions specific to Raspberry Pi that we're going to use. Then you can choose your storage, right? I don't actually have any storage set up right now. And on the next screen, if I did have the storage in there, we would see options to set a user. So you can change the default. You have to believe the default user is Pi, but you can change the default user. You can set a different password besides the default, and you can also provide an SSH key, and there's a box that you can check to enable SSH. So I've done all of that, and I flashed the SD card, and I have booted up one of these 3 Raspberry Pis, this one right here, off of that flashed SD card. So now what we need to do is actually copy the operating system that's on the SD card onto the NVMe so that we can boot off of the NVMe. So the command to do that, and I'll just SSH into the Raspberry Pi. It has a default host name of Raspberry Pi, but you can also change this in the configuration tool. I have left it as Raspberry Pi so that I know which one is booted off of the SD card, and I don't change the host name until after I have rebooted them off of the NVMe, and that way I know that they've booted off of the NVMe really quickly just by the host name that they report to my router. So we'll just SSH in. You can see I had my SSH key already loaded, and SSH is already available, so we're right in. And then we're going to run this command here to copy all of the blocks on the flash card, on the SD card, to the NVMe. That's going to be NVMe 0 and 1. So this will take just a minute. So if there are any questions about the setup or anything that I've done so far, now would be a great time for any questions.
Yeah, so right now I do not see any questions for
Okay.
now. People are still signing in. Yeah.
Okay, we can all just hang out and sing the Jeopardy music in our heads. This will take just a minute. It's copying the 32 gig. This will be faster actually. This is faster if you use a smaller SD card. So if you use like a 16 gig or an 8 gig SD card, this will be a little bit faster. I'm using a 32 gig SD card, so it takes a minute. It's hard to buy 8 gig SD cards these days. And I've already done this on the other two nodes, so we won't have to wait for this 3 times. Just because I know this was going to take a minute and I didn't want us to have to wait. But I wanted to show the whole process on one of the nodes. So while we're waiting for this, I'll kind of explain what we're going to be doing next. Next, we're going to install K3s. Awesome tool. We're going to set up one of the Pis as a control node, control plane node. You could set up all 3 as control plane nodes if you wanted to. For sort of the testing and development purposes that I'm using this for, I don't need the additional overhead. I'm more interested in testing, ClickHouse high availability than Kubernetes high availability. And then we're going to use Cilium as our CNI. This provides some nice conveniences out of the box for running on bare metal like this, just on, I'm using a consumer grade router, nothing special. So with that kind of setup, it's nice to have L2 announcement, which Cilium comes with out of the box. Another way that you could get this would be with Metal LB. Yes, I see a question. Is the lab step-by-step shareable? I will share all of these steps in like a gist or a GitHub repo. And add a comment on the recording with a link to that. I have run through this all before. The last time I ran through these remaining steps was in January. So as we all know, with software, things can shift, right? Like if I accidentally used latest for something somewhere, I didn't here, but yeah, so we're gonna make sure it all works today. And if it does, I'll share it. And if it doesn't, I'll fix it and then share it. Yeah, that does.
So meantime,
Go ahead.
Yeah. So it's installing. So I would like to ask one question to you. So why would I want to build my own cluster like this? I mean, why would
Yeah, that's a great question. Honestly, I think having a little cluster like this, it's great for just like learning purposes, learning how all of these pieces work, learning how high availability works, just the process of setting it up. You can really learn a lot. Once it is set up, it's really convenient to have a local cluster that costs you nothing that you can just run experiments on, right? Like I maintain some of our Helm charts, so it's really convenient to not have to spin up an entire EKS cluster, which, it's very easy to do that with Terraform, but it still takes a minute for all of the VMs to spin up. It costs money, whereas this is just kind of sitting there. And I can use something like vCluster on top of this to create different development environments for the different types of experiments or things that I might want to be running. You can also use this for home production purposes, right? Like there's home lab. This is kind of my home lab, but you could also have home production. So that would be running things like Pi-hole, or your own photo syncing services. So those are all things that you could do with a cluster like this. In my experience, I found that it's actually better to keep those home production services simple. We might think that we need high availability in our home production, but the biggest cause of downtime in my home prod has been me messing with things. So I try to keep like I have Home Assistant running on my house. It's running on a single Raspberry Pi. It's not running on a cluster. And that keeps things simple. And it's just one thing that I have to make sure it's plugged in and working. And I never touch that when I'm messing around with experiments with K3S and things like that. So this is sort of my, I need a Kubernetes to mess with cluster.
Wow, that's awesome.
Minikube would work fine. To be honest, my original idea for this project was to use Talos, but Talos doesn't have the correct drivers for Raspberry Pi 5, so it would only run on 4s, and 4s didn't have the PCI Express for my NVMEs. So this is kind of one of the drawbacks of running on Pis and running on ARM, is that you don't necessarily have all of the operating systems and fun things available to you. Like I also thought about using NixOS, but that was challenging to get working on Pi 5s. Oh, here we go, it's done. But yeah, I do believe Minikube would work just fine on Raspberry Pis. I'm more familiar with K3S, so that was what I ended up using. Okay, so now that we're done with that, we're going to shut down. And make sure that we unplug the correct Pi, and we're going to unplug this D card first. And this is why it's handy sometimes, like Pi kits come with a little like click on off USB adapter, so you don't have to wear out the plug by unplugging it and plugging it in like I just did. But it should boot up in just a second. And I have the SD card here, so we know that's going to boot off of the NVMe. It's not ready yet. It's still flashing, doing some stuff. There we go, we're in. Okay, so I said that Raspbian comes with a nice utility for managing Raspberry Pis, and this is one of the reasons why I like to use official Pis instead of some of the other brands that are available. You can definitely get more power per dollar from other brands, but there's just a convenience factor and a compatibility factor to using name brand Pis. And this is one of them. So we get this Raspberry config utility, and we can go down to, first we'll change the host name. Okay. And we're going to call this one Pi 1. The other ones are Pi 2 and Pi 3. And we're not going to reboot yet because we have one more step. We are going to expand the file system. So if we look right now, we can see that our file system is only 28 gigs because that was the size of the SD card that we copied. So we need to run this command to expand the file system to use the entire volume. Okay, and now we'll reboot. Oh, we can't see the bottom of my terminal. That's unfortunate. I'll try to hit enter a few times after everything I do. Okay, it should be booted up. Oh, it has a different host name now, of course. Yes. Okay, so we're in. Next, I haven't actually found this step to be entirely necessary, but the instructions say to do this. So we're going to edit our C group settings and, oops, quote there. Firmware command line. Oops, did not want to do that. Okay. And we want to add C group enable equals CPU set C group memory is 1 C group enable equals memory. Okay, save that, and then we need to update the firmware and apply that change. Yes, we would like to proceed. Okay, so it's just updating the firmware. This should be pretty fast. Okay, a reboot is needed, so we will go ahead and reboot. Give it a second to reboot. It's just taking a minute. Oh, is it ready? I'm sure there's a way in Z shell to run this command until it connects, but I don't have that shell foo. That's still working hard. Reading from the NVMe. Okay, almost still flashing. So I do have the official Raspberry Pi active coolers on each one of these. Mostly they don't do anything except on boot up, although when I've been running heavier ClickHouse workloads, the Pis can get a little hot, and sometimes the active coolers do kick in. So it is nice to have them there. And the NVMe's themselves can also get a little hot. So it's nice to have some airflow over this whole setup. If you wanted to recreate this, I would maybe recommend like if you have access to a 3D printer, it might be possible to build a slightly better case than what I have here. I'm using the off-the-shelf cases usually don't have space for the hats. So I'm using a NVMe hat for each one of these Pis, and it adds a little bit of space. I would also recommend, if you wanted to recreate this, looking into a Power over Ethernet plus NVMe hat. They're a little more expensive. They're like $30 each as opposed to like $10 for just the plain NVMe hats. But then you can create a much cleaner cluster where each Pi just has a single Ethernet cable coming into it, providing power and networking. Okay, so we're in, and we are now ready to install K3s. Let's get our... Are there other distributions more lightweight than K3s? I don't know, like, it depends how you would measure lightweight. One of the reasons I wanted to use Talos Linux is because it's an entire Linux distribution specifically built for running Kubernetes. So it includes only the binaries necessary to run Kubernetes. It doesn't even have SSH, and it's all managed by an API. So in my mind, in terms of when I think about lightweight, I think about the number of things that I have to manage, and that's one of the reasons why Talos really appeals to me. I find K3s to be perfectly, in terms of performance, which is probably what you're asking about, I find K3s to be perfectly performant on these Raspberry Pis. I don't know, maybe there are some performance comparisons out there. All right, so let's go ahead and install it. We're using mostly the defaults. We're setting one additional flag, which is to set Flannel backends to none, because we're going to use Cilium. We're going to use our own CNI. So by default, K3s installs Flannel for you, as well as a few other things. I believe it comes with Traffic load balancer out of the box. Yeah, no problem. Okay, so now K3s started. And I believe it's dropped a kubeconfig file in our etc. directory. Yeah, there it is. So what I'm going to do is disconnect and copy that file to my local host. Josh doesn't have access to that file. Okay. And now we just need to oh. Okay. We need to change the server to Pi1. Oops. Okay. And then and then we should be able to connect with K9s. Yep, and there we see we have a cluster. We don't have any pods yet because there's no CNI, there's no networking, so it doesn't have a way to connect to the internet and download the images and create these pods. But we can see that it's tried to create a Trafic pod local path provisioner. This is really nice because we're not going to have to set this up later when we want to create persistent volume claims. And the metric server, which is, of course, nice to have. Oh, nope, that's not how we quit K9s. That's how we quit K9s. Okay, so let's install CNI. We need to add the Cilium repo. I'm on a fresh machine. Okay, so now that Cilium is installed, if we connect with K9s again, we'll see the pods initializing. Okay, we have our first pod running, the Cilium operator. While we're waiting for this, we can start installing the worker nodes. Oh, I do forget how to get the token. Let's Google it. Yeah, okay. So we're going to copy that path. Probably going to need sudo. Oh, I'm not on the server. Okay. And we're going to go ahead and export that so that we have it. Okay. And then we're going to run this command. I'm going to change that to a variable. Oh, and we want to do this on Pi too. Oh, I now won't have the token here. Okay. Go ahead and Make sure we have the token on Pi 3 as well. Okay. So Pi 2 should be connected. We'll get Pi 3 going. Interesting that we didn't get all that output on Pi 2. I wonder if I did something wrong. Nice thing is you can just run this command again. All it does is create the init scripts for K3s, I think as a systemd service. Still not getting the output on this one. That's weird. Well, at least this one's giving us an error. Oh. Did I not edit those things correctly? Okay. Hey, Roger. Yes, thanks for joining. There will be a recording available. That's there. All right. Make sure this one's updated. When in doubt, turn it off and back on again. Oh, okay, and we got output from 2 as well. What is this the same error? No, it doesn't look like it. Illegal number. Isn't this stuff fun? Okay. Let's see what's going on with the cluster. Okay, so it's getting there. But I'm guessing we don't have any other nodes joined. Yeah. So let's figure out what's going on with these other nodes. Do I have a problem in my bash or my Z shell? So does this need to be like wrapped in curlies or something? Still got that illegal number error. I wonder if this is the problem. Let's see. No, it won't let us do that. So I was just trying a different host name don't know, maybe K3S isn't reading the, nope, same error. Well, this is embarrassing. Let's see if we can. Yep. Okay. This shouldn't have been the issue, but I'm just going to try chowning back the K3S config. All right, time to Google. I don't know what project repo is. No. Yeah, the token's there. Hello? Ah. Okay. This is a little frustrating, but maybe we'll just continue with a single node cluster for now. And I'll try to figure out what I did wrong. Oh, we want Kubernetes. So we do have one node ready, and we can see Cilium. It's got a pending operator pod. Why is that? It's trying to run 2 replicas of the operator, but it doesn't have 2 different nodes with IPs available. Okay. So let's go ahead and install the Alternity operator. So to do this, I'm just going to go ahead and use this kubectl. Try to add the quote around token. Oh my God. It is going to be that simple, isn't it, Mateo? Thank you. And then am I going to need the curlies? Is it not the whole token? Yeah, it didn't work. It's definitely worth a try. Yeah. All right. Let's try that. Thank you, live LinkedIn user. I will take a deep breath. Not like this, right? No. Okay. All right. Well, if anyone can think of what I'm doing wrong here with this command, feel free to chime in. But in the meantime, we'll continue with installing ClickHouse. So ClickHouse is a clustered database. It's great for analytics workloads, right? It's really, really good at aggregating across billions of rows really, really quickly. And it's really great at ingesting data really, really quickly. So if you have, insert heavy workloads, insert and read heavy workloads without a lot of updates and deletes, it's really, really great at handling extremely large volumes of data. It's very horizontally scalable. This little cluster I use for demos, and I run it replicated, but you could run on just one of these Raspberry Pis, a demo app that we use that ingests every single post on Blue Sky and analyzes them for token frequency. So that's very easy to do with ClickHouse on an 8 GB machine. And Blue Sky has around 300 to 400 posts per minute, per second. Okay. So, no, sorry, that is per minute, not per second. Okay. So we're going to go ahead and install the Alternity operator. And this is an open source operator that we maintain at Alternity. This is probably the easiest way to run ClickHouse in Kubernetes. We use this to manage our own cloud offering, where we offer ClickHouse as a managed hosted service. So it's very battle tested and very easy to use. It provides a CRD, which we're going to use via a Helm chart in order to create a cluster. So we can see that worked. We should see some pods coming up. Yep. And we're going to see the same situation. We're just going to try and create 2 pods. We won't be able to. Once that's created, we'll go ahead and install our ClickHouse cluster. wonder what the Pi thinks its host name is. Pi1, right? Yeah. Okay, so we have the ClickHouse operator running, and now we will go ahead and use this Helm repo, which has some nice defaults. Oh, I didn't want to call it that. All right, I already had it with the correct name. And then we'll take this and we'll go ahead and install ClickHouse. So this Helm chart provides some convenient values. It's also pretty easy to just install the CRD directly. If we look at the Helm chart, so you can see we've got a bunch of values, like if we want to use anti-affinity, which prevents ClickHouse from scheduling multiple replicas on the same node. That's set to false by default, which is nice because we just tried to schedule 2 replicas and we only have a 1-node cluster, so it'll just work. But in a more production-like setup, you would definitely want to set this to true and have each node, each ClickHouse node, fully consuming an entire Kubernetes node. You'd also want dedicated nodes for Zookeeper or Keeper. You can use either Zookeeper or ClickHouse Keeper. This is what manages coordination between ClickHouse nodes and replication across multiple nodes. And so you want usually exactly 3 instances of Keeper. And that is, if we go back to here, we'll see that's what we have by default. So it's only created the first 2. It'll get to the 3rd one as the PVC's provision. This is one of the nice things about using the Altinity operator, is that from that single CRD where we define a ClickHouse cluster that we want, and I can show you what that looks like. Right, so this is the, let's just edit that so it looks like this. So this is the CRD that defines, how the cluster should be organized. And it's pretty simple to edit this directly and change the settings. But the Helm chart just provides some nice convenient values to do that as well. Go back to pods. Right, so now we can see that we have our 3rd Keeper pods being requesting scheduling, which means the first one's got its PVC bound. And we see the ClickHouse node is terminating. So something went wrong there. Maybe it was waiting for Keeper to start and it terminated because it couldn't connect to Keeper. Just take a sip of water and wait for these pods to sort themselves out. You can see the persistent volume claims. Yep, so there's one bound for the first ClickHouse replica. Version of the internet. Here. Oh, you can't see that. Here, can I make this window a little? Oh, did I get a newer version than when I ran this last time? This needs to be something else. Yeah, that's what we're looking at. We're gonna, okay, that's a good idea. Let's add -v. Where did that none come from? Oh, no, that was supposed to be there. Yeah. -X. I love this live debugging. Thank you for pairing with me, Mateo. Really appreciate it. Okay. No. All right. Well, back to our ClickHouse cluster. Let's see how that's doing. Yeah, I tried -X. It didn't give us anything more verbose. Okay, we still have 2 pending volume claims. Those are taking a minute. Waiting for pod to be scheduled. The pod is scheduled. After SH. Okay. On that side. Not at the end. I think it's a problem with those C group settings. Oh, you got it? Oh, these aren't scheduling because they do have that anti-affinity set. We do have our 2 ClickHouse nodes now. Okay, and I see that we only have a few minutes left, so I'm going to go ahead and show that our ClickHouse cluster works, even though it's running on a single node with a kneecapped keeper that's also running on a single node when it wants 3. But we shell in. We can go ahead and run ClickHouse client and run some queries. So let's see if we're connected to keeper. No, because keeper's not happy because it only has 1 node. So we couldn't actually create, if we try to create a replicate table right now, I don't think it'll work. So let's maybe downgrade keeper. And then I believe it's replica account. Okay. Names are hard. You see, you've got replica account and replicas account. Let's just delete you. There you go. Oh, no, because of the CRD, they're just going to come right back. Rather, they're a stateful set. This is we restart a ClickHouse node, will it connect to Keeper? If anyone has any questions, I've got about 5 minutes left and I'd love to answer any questions. I think we did pretty well. An hour was a little ambitious for getting a 3-node cluster up and running. The first time I did this, it took me probably 3 or 4 hours pair programming with a colleague. What is the use of Cilium Envoy? I didn't choose to install that. I believe it comes out of the box with Cilium. So it's probably redundant here with Traefik. You could use either one, and there's probably a flag when you install Cilium that I missed that would prevent it from installing Envoy. I'm not sure if it's a required component of Cilium, but it is a load balancer similar to Traefik. Okay, it's restarted. Let's see if it's connected. Yes, okay, now it's connected to a keeper. We can create some replicated tables. So I'm going to go ahead and just create this test replicated table. I have a typo somewhere. Oh, that is a straight B. Okay, so our table is created. We're going to insert 10 numbers into each replica. And then if I go ahead and select, okay. Oh, the other replica is not connected to Keeper yet. We force that to reboot and connect to Keeper. Make sure this is connected too. Yes. Okay. And there we go. So we see a response from both replicas. Now, of course, both of these replicas are running on our single node, but we could imagine that we had actually gotten the other 2 nodes running, and we had one of these ClickHouse replicas running on one of the other nodes, and we're starting to get towards something that could be used to replicate a high availability setup. Hey, Saloni, any other questions?
So I do not see any other questions, but I have one. So how do we achieve high availability and backups here?
Great question. So we also, at Altinity, we make a tool called ClickHouse Backup. It's one of the most convenient ways to back up ClickHouse, whether you're running the binary directly or running Kubernetes using the operator. If you use our cloud manager, which is available in our cloud, but also in your own environment, it comes with templates that create, it actually, the base template uses 7 nodes. And I forget the exact breakdown, but I believe it's 3 Keeper nodes, 3 ClickHouse nodes, and 2 backup nodes, and maybe 2 ClickHouse nodes and 2 backup nodes. So yeah, you'd want to run, again, dedicated nodes for a true production setup. And this is why Raspberry Pis are nice, because we can have as many full dedicated nodes as we might in a true production setup, right? It'd be pretty easy to expand this cluster to 7 and have that exact setup that we would be doing with much larger like EC2 instances on Amazon.
Yeah, thanks for that. and we really enjoyed your live troubleshooting, and we really enjoyed your demo. And do paste the link, setup link, and the ClickHouse
Yes.
link for the audience. And for that, I would like to conclude this stream. And thanks everyone for joining the latest episode of Cloud Native Live. We enjoyed the interaction with Josh a lot, and with you people as well. And thanks for asking questions. Thanks for joining us today, and we hope to see you again soon. So, bye bye.
Bye. Thanks so much.